Hello, everyone. Thank you for taking the time out to hear our presentation. We are Christina Valderrama, Nino Lazaria, and Purandia Vij, and we are going to talk about hydrogen combustion technology. So, in our paper, we are going to be discussing how the hydrogen induction combustion engine works and what the trade offs between the traditional combustion engine and hydrogen combustion engine looks like. Our key motivation behind this research was the fact that all three of us come from metropolitan cities in different countries, from United States, India, and Russia, where one of the significant environmental problems include emissions from the transportation sector. The problem essentially is that transportation sector emits 30% of the total greenhouse gas emissions at the moment, and road vehicles consume 50% of the total oil product produced. For our research, we wanted to look at few potential solutions to solve this problem. We found that working with alternative fuels and technological innovations could be two potential solutions. Where alternative fuels like ethanol, methanol, biodiesel, and propane can help us reduce emissions, we wanted to specifically focus on hydrogen because hydrogen is the only fuel that has the potential to produce emissions that are free of hydrocarbons, carbon monoxide, and carbon dioxide. So for our project, we are going to be specifically focusing on how hydrogen internal combustion engine works.
In the case of hydrogen combustion, hydrogen is burned in a modified gas turbine engine to generate thrust, and the construction of hydrogen engines is similar to the ordinary. However, it helps to fix several problems such as low power output, emissions, and irregular combustion. Hydrogen can be used in spark ignition as well as compression ignition engines. The spark ignition uses spark to ignite the fuel, and in compression ignition, the air is compressed within the cylinder and the heat of this compression air is used to ignite the fuel. Because of its properties, hydrogen is more suited for spark ignition as it has a higher combustion temperature. So how spark ignition engine works? During the intake process, fuel is mixed with air and introduced into the cylinder. Then the piston compresses the fuel-air mixture, which is ignited by a spark, and the ignition results in combustion. The expanding combustion gases drive the piston, which rotates the crankshaft, and this rotational motion turns the wheels in the case of automobiles. In compression ignition combustion, it's initiated by the hydrogen acting as an ignition source. We're going to look at three fuel induction techniques or delivery systems, and the first is fuel carburation technique or central injection. And because the carburetor is often employed in gasoline engine, the hydrogen fuel gasification process may be simply utilized. A big advantage of it is that the pressure does not need to be as high as with other methods, but the disadvantage is that it results in 15% loss of power. In this case, fuel-air mixture in the intake manifold may ignite or the flame may backfire. Second technique is port injection, and it injects fuel directly into the intake manifold at each intake port rather than drawing fuel in a central point. The unfavorable effects of the carburizing technique, such as premature aging, shrinkage, and shock formation, can be removed using this technique. And the third one is direct injection systems. It's more technically sophisticated mechanism in terms of performance and efficiency. Hydrogen is directly injected into the combustion chamber at the end of the compression stroke. Because hydrogen disperses quickly, mixing it with air causes the flame to immediately spread.
As part of our research, we also wanted to look at the trade-offs of the hydrogen internal combustion engine versus the traditional combustion engine. And so we will be discussing two upsides and a downside of using a hydrogen internal combustion engine. So the first one is that hydrogen has a high flammability property, which means that it could be up to 75% more flammable depending on the fuel and air mixture. This is very high as compared to very low flammability rates of gasoline, which is about 2%. A significant advantage of this is that hydrogen can run on a lean mixture, which means that less fuel is needed. Additionally, the high flammability of hydrogen leads to ultra-efficient engine operation, which results in lower NOx emissions and increased brake thermal efficiency. Another property of hydrogen is its very high diffusivity. Basically, it's that the ability of hydrogen to disperse in air is much greater than that of petrol, which basically has two advantages. First is that it forms a homogeneous mixture of fuel and air. And second, from the point of view of application safety, it disperses rapidly in the event of a hydrogen leak, making it relatively safer and in a way keeping its high flammability in check. In contrast to these, one of the downside is that it needs high pre-ignition temperature. So basically, auto-ignition temperature of hydrogen is 853 Kelvin, which is significantly higher than that of other fuels. This makes ignition difficult when relying on temperature increase during compression, and so its ignition is difficult without an additional ignition source, which calls for a more complicated engine design. A key takeback from our research is that the combustion of hydrogen with oxygen produces water vapor as its only product. However, when combustion happens with air, it can produce oxides of nitrogen at high temperatures. Although there can be some potential oxides of nitrogen being produced, the hydrogen internal combustion engine generates only little or no carbon monoxide, carbon dioxide, sulfur dioxide, or any other particulate matter emissions which are essentially emitted in a traditional combustion engine.
Currently, the price of hydrogen is more than double that of diesel and petrol on a mass basis. And the cost is actually the main setback for the wide-scale use of compressed hydrogen tanks because the material and assembly are very expensive. Also, hydrogen cost depends on the process applied for its production, as well as the primary energy source and the model adopted. So, how sustainable is HICE? It is very sustainable due to, first of all, as was discussed previously, low emissions. Secondly, it doesn't create sustainability and integrity concerns around the supply and recycling of precious metals or rare earths. Also, it has relatively high efficiencies, and it also meets the strict EU regulations, and HICE also emits significantly lower levels of other pollutant species compared to diesel-powered engine. This table compares three zero-emission technologies, and clearly HICE powertrains are a viable alternative to battery electric mobility and fuel cells, especially for light and heavy-duty vehicles in the medium to long terms with regard to both the CO2 equivalent and performance characteristics.
As with all innovative technology, hydrogen combustion engines come with benefits and drawbacks. Some of the most important strengths to consider include their ability to reduce our reliance on fossil fuels. These engines can help countries meet increasingly stringent emission reduction targets. Additionally, they'll aid with energy security. Since hydrogen can be produced domestically, it can help to diversify our fuel sources. Another important benefit includes their ability to reduce harmful tailpipe emissions. HICE engines only emit water, which significantly reduces pollution and helps to improve air quality, which can be particularly helpful in urban areas. Finally, there are added safety measures. Fuels with lower densities, higher diffusion coefficients, and higher specific heats are safer, and since hydrogen is a very light fuel, 4 times as diffusive as natural gas and 12 times as diffusive as gasoline, this significantly reduces the risks of explosions. There are also some weaknesses that are important to consider. First and foremost, there are infrastructure challenges. The current infrastructure realities could impede the success of hydrogen-based transportation systems. Gas pipelines are expensive and can't transport hydrogen long distances. Storing hydrogen is also very challenging. When compared to gasoline, hydrogen requires about 4 times more volume for storage when stored as a liquid and approximately 19 times more volume when stored as a gas. Lastly, reducing greenhouse gas emissions greatly depends on how hydrogen is produced. At the moment, the overwhelming majority of hydrogen is produced using non-renewables, so developing the market for green hydrogen, which is hydrogen produced using renewables, is key to making this technology more sustainable. There are some challenges that we believe hydrogen combustion engine manufacturers should focus on overcoming. Some of the most pertinent include needing to reduce premature ignition. There are methods that are being developed to help with the occurrence of pre-ignition, such as utilizing a suitable dedicated spark plug design. Recently, using hydrogen as an additive to hydrocarbon fuel systems is being considered to produce higher performance rates than hydrogen-only internal combustion engines. Using the dual fuel strategy can increase the combustion stability and thermal efficiency while decreasing the carbon monoxide and unburned hydrocarbon emissions, and also decrease fuel consumption. In conclusion, we believe that HICE vehicles can play a significant role in achieving zero-emission vehicle requirements. And very recently, Subaru, Mazda, Toyota, Kawasaki, and Yamaha recently announced a joint effort to expand the use of alternative fuel technologies, including hydrogen combustion engines. So technological advancements will only continue to make hydrogen combustion engines more efficient and a more viable option for all consumers. An area of research that we as a team discussed that we would like to delve into in the future would be the development of the green hydrogen industry and finding ways to produce hydrogen in more sustainable ways. Thank you very much for listening to our presentation.
Hello, everyone.